In this example, we're given that log base b of x is 0.36 and log base b of z is 0.83, and then we're asked to find log base b of the square root of x divided by the cubed root of z. What this is essentially an exercise on the properties of logarithms. So let's bring those up. Here they are, and this is certainly more than we need for this particular exercise, but it's good to have these internalized, right? You want to be able to use these without having to look them up. It takes some time to get them down, but the more you use them, the more they set in. So let's see what we can do here. Well, okay, right here, it tells us that dividing inside a logarithm turns into subtracting outside of a logarithm. So let's go ahead and do that. So what we really have is log base b of the square root of x minus log base b of cubed root of z. Now, none of our properties of logarithms say anything about radicals inside of a logarithm, but we do have something about powers inside of a logarithm, right? And what it tells us that log brings this power, this exponent, down to the front. So let's write these radicals in exponential form next. So we have log base b of x to the 1/2 minus log base b of z to the 1/3. Now we're getting somewhere. 1/3, okay. Now I'm going to use this property down here with the exponents to bring the exponents down to the front. So down comes the 1/2, down comes the 1/3. So we really have 1/2 log base b of x minus 1/3 log base b of z. But we know what log base b of x is. That's 0.36. So this becomes 1/2 times 0.36 minus 1/3 times log base b of z. We know that that's 0.83. And now we simply break out the calculators and put in those numbers, crunch it through. Turns out you get negative 0.096 repeating. And depending upon what the specific question wanted, you could round that or not. I'll just leave it as repeating in this case, and that does the trick.